before we start talking about the product rule and quotient rule, let's take a look at all the differentiation rule we learned so far. So the first one is a constant function. So constant function is, let's say you take the derivative of 6. The derivative of 6 is equals to 0. Because 6 is a horizontal line, the slope is equals to 0. And then constant multiple rule. So let's say you have 6x to the fourth. So you take the derivative of that. You bring the 4 down. So you put the 6 aside, bring the 4 down, and then x to the 4 minus 1 is equals to 3. So that is 24. X to the third. So that is a constant multiple rule. And also when you bring the power down and then take the power minus 1, we also apply the power rule. And then the exponential function e to the x, doesn't matter how many times you take derivative, it is always e to the x. And then the last one, we have another exponential function that is b to the x, and b is any non-zero base. This one you won't use that very often. This one is b to the x times ln b. And then here we have product rule and quotient rule. So if you want to take away all the x, I have a simple version for you. So this one we have f times g. That means we have one function times another function. When you take the derivative of this, you have fg prime plus gf prime. And then if you have one function divided by another function, f divided by g, that is gf prime minus fg prime divided by g squared. So gf, fg, gf, and then gf, fg divided by g squared. Okay, and then when do we use product rule? So in the first function, you have one polynomial multiply another polynomial. So that is the product of two functions. This one is a product rule, and then this one is a quotient rule. All right, let's take a look at the first problem. So the first problem we have, I want you to differentiate the following function. So a, we have f of x equals to 3x squared minus 5x times e to the x. So for the product rule, we have fg prime that is equals to fg prime plus gf prime. Okay, so this is my function f, this is my function g. Then f of prime of x, fg prime, so you take the derivative of e to the x, which is still e to the x. So that is still e to the x. And then plus, product rule is plus, and then you copy function g, you take the derivative of f, so you bring the 2 down, so that is a 6x minus 5. So to me in person, I will just take that as the answer. But if you, it doesn't matter which textbook you use, most of them, 99% of them, they want you to simplify all the way to the end, which means you have to distribute the e. So that is a 3x squared times e to the x minus 5x e to the x plus 6x e to the x, and then minus 5x 5e to the x, and then you can simplify these two, right? Negative 5 plus 6, so negative 5 plus 6, that is equals to 1. So you have 3x squared ex plus x e to the x, and then minus 5e to the x. The reason I prefer to take that as the final answer is because this section is about using quotient rule and product rule, right? This section is not about how to simplify a polynomial. So to me, the simplification is not really that important. All right, the next one. The next one we have b. We have h of u equals to u minus the square root of u, and then u plus the square root of u. Oh, when you apply the product rule, if you want to do it in a slow motion, here is how you do it. So this is f, this is g, right? Product rule, you have fg prime plus gf prime, right? So here is the slow motion. So you find the h prime of u. You have f, you copy f. And then you take the derivative of g, right? So this is how we do it. We write the derivative with respect to u. So that is u plus the square root of u. You set up the derivative, but you are not taking the derivative right now. And then plus g, and then times the derivative of f. with a little bit of practice, I don't think that you have to waste time to write this line. Okay, so if you decide to do so, that is fine, that is good. But after you solve like 3 to 4 problems, you won't need to do this anymore. So this is a u minus square root of u, and then the derivative of u is 1. You bring the 1/2 down, and then 1/2 minus 1 plus u plus the square root of u. This one is 1 minus, you bring the 1/2 down, 1/2 minus 1 is negative 1/2. And then you distribute all of this. So you have u times 1, so that is u, and then plus 1/2, so that will be a 1 minus 1/2. You subtract the exponent. Actually, you add them, but due to the negative 1/2, you have 1 minus a half. So you have a half, and then minus u to a half, and then minus 1/2. So this will be the this one times that one, so that will be just a 1/2, right? Because you have 1/2 plus negative 1/2. Okay, and then plus this, you have a u minus 1/2, 1 minus that, and then plus u to the 1/2, and then minus this, you only have a 1/2. And then any cancellations. I can see that this one and that one will be cancelled, right? And then this one and that one will be cancelled. What about the 1/2? This is a minus. This is also a minus. So that will be u plus u. So that is equals to 2u. And then minus 1/2 minus 1/2. So minus 0.5 minus 0.5, you have a minus 1. So that will be a 2u minus 1. To me in person, again, I think that this is the final answer because it's easier for people to grade, right? I can clearly check your derivative. The purpose of this lesson is not about expanding binomial and then simplify the like terms. Okay, moving on to the next problem. So the next problem, we have C. So C is we have f of y that is equals to 1 over y to the third. This is a 3. Let me make the eraser smaller. And then minus 3 divided by y to the fourth times y plus 5y to the third. So we have f, we have g. So this is your f, this is your g, and then we do f prime of y. What's the product rule? The product rule is fg prime plus gf prime, right? So we copy function f. So that will be, let's put all the let's get rid of all the fractions. So that is y to the negative 3 minus 3 times y to the negative 4, and then g prime, you take the derivative of that. The derivative of y is equals to 1, and then that one is 3 times 5, and then 3 minus 1 is 2. And then plus gf, so we copy g, and then f prime, so bring the negative 3 down, y to the negative 3 minus 1, and then bring the negative 4 down, y to the negative 4 minus 1. There you go. To me, I like to put that as the final answer. So we don't need to deal with the expansion. We don't need to deal with the simplification. But to most of the textbook, they would like you to do it. Let's do it anyway. So we expand that. So that will be y to the negative 3. And then plus 15, negative 3 plus 2. That is a negative 1. And then minus 3y to the negative 4, and then minus 45 y to the negative 2, and then plus right here, so negative 3 y to the negative 3, and then plus 12 y to the negative 4, and then plus, it's not plus anymore, it's a minus, minus 15 y to the 3 minus 4 is negative 1, and then plus 60, 3 minus 5 is negative 2. And then we are trying to simplify some like term. Let's see. So this one we have this and that, they are like terms. And then the fourth power, anything else? And then we have the first power and the second power, right? So the second power, the first power, let's don't underline that. Okay, so we have 1 minus 3, that is a negative 2, y to the negative 3, and then the fourth power, we have a negative 3 plus 12, that is 9. And then we have the second power is negative 45 plus 60, that is a 15. What about the first power? Oh, the first power is cancelled, 15 minus 15. So that will be your final answer. Some textbook might want you to do this. 9 divided by y to the fourth minus 2 divided by y to the third plus 15 times y squared. They have negative 2, right? Okay, they have negative 2. So that will be 15 divided by y squared then. Okay. Moving on to the next part. Let's change color for the next one. So the next one we have part D. So part D we have f of z equals to 1 minus e to the z, and then z plus e to the z. Okay, so this is f, this is g. The product rule is fg prime plus gf prime. So f prime of z, that is equal to, copy the f, and then take the derivative of g. The derivative of z is 1, and then ez is always ez. And then plus copy the g, and then take the derivative of f. The derivative of 1 is 0. Feel free to write the 0 out. The derivative of negative e to the z is just e to the z. To me, again, I will take that as the final answer, but most of the book would like you to simplify all the way to the end. So that means you have to expand, right? So 1 plus ez minus ez minus e to the ez times ez. Z plus z is 2z, and then plus z times negative e to the z. So that is minus z ez. And then ez times itself is minus e. Z plus z is 2z. Okay, let's simplify. We have a plus minus, they are cancelled instantly. And then we have a negative, we have a 2z, so that will be a 1 minus 2e to the 2z, and then minus z e to the z. Okay, so that would be the derivative. Okay, just a few notes for you. So ez times e to the z, that is equals to e to the z plus z, e to the 2z. All right, just like x squared times x to the fifth, that is same base, right? X to the 2 plus 5. If you have x squared raised to the fifth, then that will be 2 times 5, x to the 10th. Just a quick review. Okay, part E, more exponential function. So part E, we have y equals to e to the p, and then p plus p, the square root of p. Okay, so let's simplify that, e to the p, and then p plus, so this will be a p times p to the 1/2, right? Then that will be 1 plus 1/2, then you have a 3/2. Now we take derivative. Y prime, again, fg prime plus gf prime, keep writing this. So you don't need to spend extra 5 minutes to memorize the formula. So copy function g, so that is e to the p, and then derivative of the parenthesis, so that will be a 1 plus, bring the 3/2 down, minus 1, so that will be a 1/2. First part is done, and then plus copy function g, and then take the derivative of f, which is still e to the p. To me, I will take that as a final answer because it is easy for me to check your work. But if you do your homework in online, they would like you to simplify all the way to the end. So EP plus 3 half P EP times P to the 1 half, and then plus EP times P plus EP P to the 3 half. I don't see anything that we can combine. The best you can go is you factor out the e to the p. So you have 3 half p to a half, or they would like you to put that in a square root. All right, and then plus p, and then the p to the 3 half. They would like you to put that as the square root of p to the third. Oh, we wrote an extra p. We don't need this p. We missed something, right? We missed the 1 here, right? We take the e out, we miss a 1 plus. Then we have that, and then we took the EP out, and then we plus p, and then we plus the last term, right? So 1 plus 3/3 square root of p plus p plus p to the 3 half, which is the square root of p to the third. Okay, so that is the final step of part E. So the next one, we will be doing quotient rule. Let's switch color for that. So part F is a quotient rule problem. So part F, we have g of x equals to 1 plus 2x divided by 3 minus 4x. Again, there is no way to simplify this rational function. What is the quotient rule? The quotient rule is you have one function divided by another function. The top is f, the bottom is g. So this you have gf prime minus fg prime divided by g squared. The product rule is fg gf, right? So the quotient rule continues at the gf. So you have gf fg divided by g squared. So the slow motion, g prime of x, we draw a long fraction bar. Function g is the bottom. And then you take the derivative of the top. I am not going to take the derivative right now. I will just state the derivative notation. And then minus function f, which is the top. And then the derivative of the bottom, d dx. And then 3 minus 4x. There you go. And then the denominator, you just square the denominator. You don't need to square that out. So when you do quotient rule, you always keep that as in square. And then you take the derivative, simplify the top, and then you will be done. So g prime of x, that is equal to 3 minus 4x. And then that will be a 0 plus 2, right? Because the slope of 1 plus 2x is just a 2. Minus 1 plus 2x. And then the derivative of that linear function is negative 4. Divided by the denominator. And then you open up the top. So that will be a 6 minus 12. 12. That will be 6 minus 8 x. And then minus minus, that will be a plus, minus 8x. Divided by 3 minus 4x squared. So we have 6 plus 4 is 10. That negative. This will be minus minus, then that will be a plus. So this is only a 10 divided by 3 minus 4x squared. So that is the final answer. So far so good. Let's do the next one. The next one is g. So that is y equals to t to the third plus 3t divided by t squared minus 4t plus 3. Okay, let's do the slow motion. So the next problem, we won't be doing that slow motion again. So y prime is equals to, what is quotient rule again? Quotient rule is gf prime minus fg prime, the whole thing, divided by g squared. So we immediately square the denominator. All right, and then gf prime, so we copy the denominator, and then we take the derivative of the top, minus, quotient rule is always minus, and then we copy the top, times the derivative of the denominator. All right, that's the setup. Let's move this up. So y prime is equal to, that would be a t squared minus 4t plus 3. This will be a 3t squared, right? Bring the 3 down, and then 3 minus 1 is 2. And then the slope of 3t is 3 minus t to the third plus 3t. And then bring the t down. So that would be a 2t minus 4. The derivative of 3 is 0. Divided by 3 squared minus 4t plus 3 squared. And then you fully open the top, and then get rid of the like terms, and then you will be done. So y prime is equal to, let's prepare the denominator, so you should have plenty of terms on top. So that is a 3t to the fourth plus 3t squared minus 12t to the third minus 12t plus 9t squared plus 9, and then minus, okay, let's put a minus in here. This is a negative 4t to the third, so you take that out. That becomes maybe we don't need to. I can put this in a parenthesis. That's fine. I don't want to jump too many steps. So that is a negative 4t to the third. Oh, we don't want to go by this order. So that is a 2t to the fourth minus 4t to the third, and then plus 6t squared, and then minus 12t. Okay, simplify. Okay, fourth power, we have a 3 plus 2. Hold on. No. This is a plus. This is a plus. Okay, we have a 3 minus 2 equals to 1. And then the third power, we have a negative 12 minus a plus. So negative 12 plus 4. That is equals to negative 8. And then the second power, we have a 3 plus 9. That is a 12. 12 minus 6. That is 6. And then first power, we have a negative 12 plus 12. That is gone. And then a plus 9. All right, so that is the final answer of part G. All right, moving on to part H. So part H, we have f of t equals to the cube root of t divided by t minus 3. The cube root, let's put the cube root as t to the 1/3 divided by t minus 3. What's the quotient rule? The quotient rule is gf prime minus fg prime divided by g squared. So we have f prime of t. Let's don't do the slow motion part. So we immediately square the denominator, and then g, we copy the denominator, and then we take the derivative of the top, we bring the 1/3 down, so that is t to the 1/3 minus 1 is negative 2/3, and then minus, copy the numerator, and then take the derivative of the denominator, t minus 3, the denominator, the derivative is 1, and then you simplify. So we have 1/3, 1 minus 2/3, and then -1 and t to the -2/3 and then minus t to the 1/3 divided by t minus 2 square. And then you have a 1/3 minus 1, you have a -2/3. T to the 1/3 and then minus t to the -2/3 divided by t minus 2 square. That is the answer. Okay, let's do some more complicated problem. Let's change color for that. Okay, let's use a green. I would like to put a problem where you have a product rule in a quotient rule. Let's go take a look. Part I, you have f of x equals to x squared times e to the x. This derivative itself is already a product rule, but we divide it by x to the third plus e to the x. There is no way to simplify this rational function. So we have a product inside a quotient. Product is fg prime plus gf prime. Quotient is gf prime minus fg prime divided by g squared. Okay, so let's take the derivative f prime of x, long fraction bar, divided by g squared, right? So x to the third plus e to the x squared. All right. We copy the denominator, x to the third plus e to the x, and then what do? We do f prime, but the f prime itself right there, that one itself is already a product rule. Okay, so we have to put a product rule right here, and then minus f, and then times g prime, which is the derivative of the denominator. So that you bring the 3 down, so 3x squared plus e to the x, right? Take care of the product rule for me. The product rule is fggf, so the derivative of this goes here. I'm sorry, fg prime gf. So we do f, g prime is still e to the x, and then plus g, and then f prime, 2x to the first. Okay, and then we expand the top, cancel some like terms if possible, and then we write our final answer. F prime of x, that is equal to x to the third plus e to the x squared. And then this we have 3 plus 2 is 5, right? So we have x to the fifth ex, and then plus 2x to the fourth ex, and then plus x squared, e to the x plus x is 2x, and then plus 2x e to the 2x. So that completes the first one, and then we have a minus right here, and then we have this. So this is a 3x to the fourth ex, and then a plus x squared e to the 2x. Any cancellations? Yep, I see one. I see this one and a minus this one. So they are gone. And then other than that, I see a x to the fourth and a x to the fourth. So let's get to the final answer. F prime of x, that is equal to x to the fifth e to the x. 2 minus 3 is -1, and then plus 2x e to the 2x, and then we have x to the third plus e to the x, and then square. So that is your final answer. Alright, so that will be all in this part. In the next part, I will teach you how to find second derivative. I see you there.